Algebra 2, Chapter 13, Section 2, Verifying Trigonometric Identities. So this is pretty similar with the end of the first section, where we are going to manipulate and change around uh, a trigonometric identity to verify it's true. An important thing about this is we only work with one side of the equation. We don't work a little bit here, work a little bit there, and then go for that. Sometimes it is handy to like look at where you're going to start, look at where you're going to end, and maybe work a little bit backwards and try to meet in the middle. But really, what you're supposed to be trying to do is start from one side of the equation and work until all of a sudden the other side just pops out. What happens though sometimes, and this is just, I'm not going to be actually like drawing it out. You got all these steps in here you're doing, and then you finally get to the end. And then you realize partway through that the third step and the fifth step were the same step, and you did this extra thing in the middle. Well, that just means you could have optimized the work and just not done that middle step. So that's the thing that happens in these kinds of problems. It's just that's what it is. I've gone through and worked on problems like this and spent a whole page trying to run around in circles with trig identities and then end up realizing at the end I could have rewritten it with three steps. It's just that's how it goes sometimes. The other tip that they give us is it's easier to work with the more complicated side of the equation, uh, and mostly because the more complicated side has more details for you of things for you to work with. Um, so let's go ahead and try some of these things. Let's try example one here. Now, when I'm looking at example one, I see a couple things. I see sine squared. So whenever I think of sine squared, I immediately think sine squared theta plus cosine squared theta equals 1. That is the Pythagorean identity. And, I've got sine squared all by itself right there. It'd be nice if I had sine squared all by itself here. So I actually have sine squared theta equals 1 minus cosine squared theta. So we just made a new trigonometric identity. If you've got that one, add it to your table. You're always going to be able to use this one. I mean, we just subtracted cosine squared from both sides. There's no problem with that, right? So that might be helpful. Um, Other things that might be helpful is, here's another thing that I see that I might be able to use. I have 1 minus cosine. Now, if you remember with the previous lesson, I said you're always going to want to remember the difference of squares pattern. So it looks to me like I have 1/2 of the difference of squares pattern. And if I were to do that, I would actually end up with the right hand side of the equation there. Almost. It seemed like something's going to happen there. So here's what I'm going to do. Let's start with sine squared theta over 1 minus cosine theta. I'm going to multiply by the conjugate. 1 plus cosine theta. This is the difference of square things I was just talking about. Now, what's going to happen here is I write where I'm going to start, and I wrote this down kind of like I'm going to be solving an equation. And you can, if you want to, write a little question mark over your deal and write 1 plus cosine theta every single time. I always found that to be kind of tedious. So I don't write 1 plus cosine theta every time. I do write the question mark though, and I just kind of leave that one alone for the moment. So when I do this, I've set it up so that In the denominator, I have, see, this little bit right here that we made is the difference of squares pattern. So I'm left with 1 squared minus cosine squared theta equals something. And on the top, well, I could multiply that out and I'd get something, but I don't really want to distribute that out. I'm just going to leave that alone. Sine squared theta times 1 plus cosine theta. And the reason why I want to leave it alone, do you see how you have what you want as a result there? So since I kind of see that pop out, I'm not going to multiply it back through because that's what I want in my end. So if I could somehow get everything else to cancel out, I can. And that is where the Pythagorean identity comes in. I say, oh, I got the one, because 1 squared is just 1. 1 minus cosine theta, which is the same as, there's just my numerator, didn't do anything there. But the stuff highlighted in blue there is the same as sine squared theta. And look at that, I have a sine squared theta on the top and the bottom now. So it equals 1 plus cosine of theta. That is how you solve one trigonometric identity. This is really a test of all the different techniques in Algebra 2. All the different factoring and multiplying techniques, spotting patterns, being able to chunk out a piece of it. That's what makes this a good skill. Is you're practicing all of those manipulation techniques until you know them really well.